This is section 10.2.2. We're going to take a look at the inverse trig functions for tangent, cotangent, secant, and cosecant. So we're going to evaluate the trig functions for those four ratios. So these are the properties for arctangent and arccosine. Now, arctangent is very similar to sine. It's negative pi to pi, but if you look at the range, you cannot include the ends. And the main reason is because, let's take pi halves, right? So we rotate pi halves. That's the value 0, 1. If I did sine over cosine, you get undefined. So you can't include it. So that's why there's a parenthesis. And likewise, cotangent is very similar to cosine. Same range. It's just the fact that, again, you can't include the bounds, because if you do, you're going to get undefined. So it's just helpful to kind of remember that. So arctangent, what angle, right? So this is angle, gives me the ratio of radical 3 that's between negative pi halves to positive pi halves, because it's tangent. And so we go to the unit circle, right? And we know here, and then that's radical 2 over 2, and then that's going to be 1/2 radical 3. So sine over cosine, radical 3 over 2 over 1/2, that's at 60 degrees. Those cancel out. There's my root 3. So I know that that's going to be pi thirds or 60 degrees. Is that between negative pi halves and positive pi halves? Yes. Now again, those things cancel out. So if you see something that cancels out because they're inverses of each other, then that's going to be your value. Now the only problem, though, is, does this match my input? Right? It's the big thing. Does that match the input? And so in this case, my domain is negative infinity to positive infinity, so yes. So my answer can be negative 5. Now the idea here is, if we have a variable like x, and then we can use it with identities, that's okay. So remember that this represents an angle, and I could say it's angle theta. So I could think of this as the tangent of 2 theta. So then that's an identity, which is 2 tangent theta over 1 minus tangent squared theta. So I just need to know what the tangent is. So if I go to create my triangle, tangent x, opposite over adjacent. Okay, well, tangent of theta is going to be x. So then I could say this is 2 times x over 1 minus x squared. Now the only thing we have to kind of think about is if there's a domain restriction. In this case, we're dividing by x. We want to exclude the domain, or we just want to be aware that we can't pick 1 and negative 1 for x. Just kind of think of it that way, because then we're dividing by 0. So even though the domain does say negative infinity to positive infinity, because of this, identity and how it was constructed, we would have to restrict 1 and negative 1 from the domain. To show you one like on number 2, because remember it's cotangent, so now it's cosine over sine. But to show one that's like on number 2, it says sine of arctangent is negative 3 over 4. So remember, this means it's an angle, so that I can draw my little hypothetical triangle, but it's negative, so my triangle is actually going to be in that quadrant there. And so tangent opposite over adjacent, so opposite over adjacent. If I use the Pythagorean theorem, a squared plus b squared equals c squared, that would equal 5. So the sine of that angle is opposite over hypotenuse. Now for arcsecant and arccosecant, the domains are very, very similar to, so we know that secant goes with cosine, And then, this goes with sine. The ranges or the outputs are very similar. It's still from 0 to pi. It's just we have to exclude pi halves because of the fact that if we look at the top, we have 0, 1. Okay, so cosine is 0, which means the secant is 1 over 0 because it gets flipped, so it's undefined. Same thing happens with sine. So we just have to exclude that because we can't include undefined values as part of our range or domain. So arc secant of 2, what we're going to do is we're going to imagine that as cosine because it just makes it easier. So if we convert it into cosine, and so now we think of our unit circle, where is my cosine going to be 1/2, and that's going to be at pi thirds or 60 degrees. Then we have arc secant and secant. Those cancel out and we get 5 pi fourths. But 5 pi fourths is not between 0 and pi. So I need to think, okay, 5 pi fourths, that's here. That's negative radical 2 over 2. Negative radical 2 over 2. There's my cosine value. So what's the equivalent version of that? That's going to be here at 3 pi fourths. So my answer has to be 3 pi fourths. Now again, to repeat that, that's because even though they do cancel out, right, the arcsecant and the secant, they do cancel out. That's all true. The problem is going to be the answer that I have, the 5 pi fourths, is not on the range. Whoops, it's this right here, of 0 to pi halves union pi halves to pi. 5 pi fourths is bigger than that. So I have to convert it, which is the equivalent of negative radical 3 over 2, that is between 0 and that pi, excluding pi halves. And that's going to be 3 pi fourths. So concluding today's lesson, we took a look at tangent, cotangent, secant, cosecant, and using the inverse trig ratios. This does conclude our lesson. If you have any other questions, please leave them in the comments.